Okay, so we're going to be looking at independent events. So we've been given our question here. There's 3 sub-questions. We'll read through it once. There are 2 tests for a particular antibody. Test A gives a correct result 95% of the time. Test B is accurate 89% of the time. If the patient is given both tests, find the probability that both tests give a correct result. So let's kind of look through this. Question number A. If 95% of the time is correct, okay, and then test B, so that's test A, test B is correct 89% of the time, we're looking for a correct result both times. That's essentially these 2 probabilities or these 2 percentages multiplied by each other. I could have written them like this. If the test is given 100 times, 95 tend to be correct. And test B, if the test is given 100 times, 89 of them tend to be correct. And then you can, whoops, you don't multiply, you can just kind of figure it out from there. But the percentage should be the exact same as the fractional answer. So I'm going to bring up a little calculator here. Looking at 0.95 times 0.89, and it gives 84.55. So 84.55, which means this value here is 8455 over, I believe, 10,000. Yes. So that means if you were to be given both tests, the probability that the test got the answer right both times is an 85% likelihood that the test has told you that you either yes have the antibody or don't have the antibody, depending what it is you have. But that's how we'd walk ourselves there. We just multiply the correct responses. For B, neither test gives a correct result. Well, that's the opposite of our C here. We're going for wrong answers. So what percentage of the time is test A wrong? Well, if it's correct 95% of the time, that must mean test A, and I'm going to do this part in question B here, test A must be wrong 5% of the time. Okay, that's test A. And test B, if it's accurate 89% of the time, well, that must mean it is wrong or inaccurate 11% of the time. Test B. So we just multiply these 2 percentages again by each other. So 0.05 times 0.11, and we end up with here 0.55%. So obviously that first 0 is not important. But what is the probability that both tests didn't give you the correct answer? So in other words, this would be the idea of them saying you have the antibody, okay, and it turns out that you actually don't. What's the probability of this event happening? Is less than 1%. It's 0.55%. So these 2 are very straightforward calculations. C is where it gets a little tricky. Okay, so like I said, C is a bit tricky. At least one of the tests gives a correct answer. Okay, at least one of the tests. So what that means here is there's a couple of different ways we can solve this. We can go through all the different options here. We can say, okay, well, what's the probability test A gives us a correct, here, I'm going to run us through in green here, C. We can say, what's the probability that test A is correct, but B is not? That would be at least 1. Test A is incorrect, but B is. Or both test A and B are correct. So there's 3 different options. In other words, kind of spelling out 3 different percentages to work with, and then we would just kind of add them all together. This is one route, but this is actually the longer route. It tends to be the more logical route, but it is the longer route. The other option is to assume that the answers from all tests will be 100%. And let's do the opposite. So the question said at least 1. Well, let's calculate none of the tests being correct, which is actually something we've already done. And then just subtracting that from 100%. Okay. So what that means is we already have that calculation we're looking for. We're looking for the opposite of what this is. So we're looking for what's the probability that none of them are correct, and then we subtract that from 100. So if we were to do 100%, I'll do it in green here, 100%, subtract that 0.55%. It should give us, let me subtract, get a calculator out, 100 subtract 0.55 equals 99.45. So there should be 99.45%. So what that means is at least one of the tests gives a correct result, there is a 99.45% chance that at least one of the tests gives the correct result. So I did this the fast way, but we can check this the other way if we like. We've already done A and B at the very top. Probability of both of them being correct we know is 84.55%. That was the first one. But we're going to double check our answer that we've done through our shortcut. What's the probability that A is wrong but B is right? Okay, well that means probability of A being wrong we already know is 5%. Probability of B being right is 89%. We can multiply those two to find out another percentage here. So 0.05 times 0.89 gives us 0. So that's going to be a 4.55% chance. So this probability gives us a 4.55% when we've multiplied 5% times 89. And then here, what's the probability that A is correct? We know that's a 95% chance. And that B is wrong, that's an 11% chance. So we multiply those two percentages, 0.95 times 0.11, and 0.10, so it's a 10.45. 10.45% chance. Okay. So now that we have all three, we said we would add them together, and that should give us the same value we got down here using our shortcut. So using our shortcut, we're going to take that 84.55 plus 4.55 plus 10.45, and it gives us 99. Oh, sorry, I added one little wrong there. That should have been 545, 55, and 55. 99 point, I got 55 here, and I'm gonna